Okay, so today's focus is going to be on compound inequalities. So compound inequalities, that's what our focus is today. And so the notes for this is just a definition. So compound inequality, those are going to be two inequalities or more. It could be more than that. Joined together with and or. Okay, so it's going to be two inequalities that are joined together with either and or joined together with or. Okay, so we're going to start with the ors first and take care of those, and then we are going to work from there. Okay, so or inequalities have a tendency to graph apart. Okay, meaning they will be going left and right, and they kind of look like an oars coming out of a boat. Okay, so or kind of like OAR, or coming out of a boat. You see how they kind of stick out? Okay, that's what or means. They're going to graph apart. Okay, so here's how they would look when you graph them. So if this were our answers for the or inequality, x is less than or equal to -2 or x is greater than 3, we would graph them up here. And so we would have a -2, and it's a closed circle because there's an equal sign here, and it's everything left of that because it's less than. So we would color this in. Okay, and then over here we would have an open circle at 3 because it's not equal to, and then greater than means everything to the right. Okay, so notice how those are moving away from each other, moving apart. And so when we write it as interval notation, we do the first interval notation or the second interval notation. That's how we write it. So from furthest left, we're going from -infinity, and that'll be parentheses, to -2, and -2 is closed, so we used a bracket. Okay, and then or, gotta include that or. Then we have 3, which is an open circle, so it's parentheses, to infinity, which is also parentheses. Alright, so that's what it looks like when you graph it. Now, to solve them, we solve them exactly like we've been solving equations or inequalities up to this point. The only difference is that we're going to graph both sections and write our interval notation. We're going to have two answers, or two sets of solutions. So basically what this means is that our answers for these types of graphs, the solutions could be any number that's -2 or less, or it could be any number that is greater than 3. Okay, and so any numbers that are shaded in, colored in, are all part of the solution. Anything that's not is not part of the solution. So before, when we did equations, there was one solution a lot of the time, and so that one number was the only thing that worked. Where here, if I had one of these numbers, I could pick any number, plug it into the equation, as long as it was shaded in, and it would work. It would be a true statement. So we can look at that here in just a minute. So we'll do number 2 together. That's where we'll start today. So first thing, I have two inequalities. I'm going to have to solve both of them. So the first one, I have -3x is less than or equal to -9. So I only have one step here. I'm going to divide by -3. Okay, notice what I said. I'm dividing by -3. And so the same rule applies today as it did yesterday when we talked about dividing by a negative number. If I divide by a negative number, I take this sign, which was less than, and I make it greater than. The equal to stays. And then that -9 divided by that -3 becomes a +3. Okay, over here, 5 plus x is less than 6. I subtract the 5, and I'm left with x is less than 1. And it's still or, okay? Or is still part of that. So here I have my two solutions. So this could mean that I could plug in any number that's going to fit in these two solutions, and they would work. So I'm going to start by graphing this one. X is greater than or equal to 3. So equal to 3 means I'm going to do closed circle. Greater than means I'm moving to the right. Okay. Here I have no greater than symbol, so I'm going to do an open circle at 1. And less than means I'm going to the left. Okay. So when you get to an OR problem, if you notice that when you try to graph it, it's not graphing away from each other, you might want to just double check that your answer is correct, that you didn't make a mistake, forget to flip a sign or something like that. If they're graphing on top of each other, there's a good chance that you're not going to have a correct answer because generally they are going to go apart from each other. Okay, so we'll do our interval notation here. Furthest left is negative infinity with parentheses to 1, also parentheses because it's an open circle, or 3, which is a closed circle, so I'm going to use brackets, to infinity. And again, infinity means I'm going to use parentheses. Okay, so that's how we would solve and graph and do the interval notation for a compound inequality. It just means that there are two inequalities joined together here. All right, so we're going to do one more example. We'll do number 4. It's a little bit more extensive than before, a couple more steps to it, and then you'll have 1, 3, and 5 to complete on your own for this. So looking at number 4, all right, we have this first inequality, 7x minus 14 is greater than or equal to 0. So to solve, we add the 14, and we have 7x is greater than or equal to 14. And then we divide by 7, and x is greater than or equal to 2. Then over here, we do the same thing. We're going to subtract 5. So 4x is less than or equal to negative 8. We divide by 4. X is less than or equal to negative 2. Now notice here, I did not divide by the negative. Okay, this number that I divided by is positive, so I do not change the sign on this. All right, up here, that negative 3 is what I'm dividing by, so it does have to be changed. But down here, this number on the bottom is not a negative, so I continue it on and I keep the same sign. Okay, so don't get confused by that. So we're going to graph it. 2, and there's an equal to, so I'm going to put a closed circle, and I'm going to go greater than that, so I'm going to go to the right. And then negative 2, there's also a closed circle, it's an equal to, and I'm going to go less than to the left of that. Okay, and so here, interval notation from least to greatest. So furthest left from negative infinity to negative 2, closed circle, so I'm going to use a bracket on that. And then here from 2, again, closed circle with a bracket, to infinity. All right, so those are how we are going to do those compound inequalities. Not too different from yesterday, just a little bit, a couple of different things that we need to keep in mind as we work through the ORs. All right, so I'm going to stop the video here. You can go ahead and do numbers 1, 3, and 5. And then we're going to flip it over to the back, and we're going to work on and inequalities. They are a little bit different, so we're going to talk up through those and make sure we know how to work them out.